Welcome to Math or Lose. I'm your host Lucia, and this is where we ask participants to solve relatively easy math questions. Let's get right into it. Alrighty, we have our first contestant,
Chloe.
Chloe. Can you please draw the sine function? Yes, that's pretty close. Now, can you please draw the derivative of the sine function? Pretty close. Let's go over it. Alrighty, Chloe was close, but not quite. Let's go over it. This is our sine function, and we can identify the zeros are at 0, pi, and 2 pi. Here we have a tangent line, and we can see that the slope is pretty much 1. So I'm going to add a maximum at 1. Now here we can see the slope of the tangent line is -1. So I'm going to add a minimum at -1. And here, this pattern would continue, and this slope of the tangent line looks like +1. So I'm going to add another maximum. Now we can see that the derivative of sine is actually cosine. And our next contestant,
Sarah.
Sarah, can you please draw the cosine function? Amazing! Now, Sarah, can you please draw the derivative of the cosine function? Very close. Let's talk about it. Sarah's graph wasn't quite correct. Here we have a cosine graph, and we can identify here the slope of a tangent line would be 0, so I'm going to add a dot here. Here we see the slope of the tangent line is -1, so I'm going to add a dot right here at -1. Here the slope of a tangent line is 1, so I'm going to add a dot at +1. And here, the slope of a tangent line is 0, so I'm going to add a dot at 0. And here, again, the slope of the tangent line is 0. I'm going to add a dot here. Now we can connect our dots, just like that, and we notice that the derivative of cosine is actually negative sine. Our next contestant.
Hi.
What's your name?
Fustine.
Alrighty, Fustine, can you please solve this equation?
Sure.
Good try! So here we have the function cosine x plus 1. Now, how do we find the derivative? Well, we have an inside section and we have an outside section. So first, let's take the derivative of cosine. The derivative of cosine is negative sine, and then we have the inner function, x plus 1, and then we take the derivative of this inner function, which is 1. And there's our answer. And our next contestant,
Marie.
Marie, can you please draw a natural log function? Very good! Now, can you please take the derivative of that?
I would love to.
Let's talk about it. Marie was also close, but not quite either. So here we have a graph of our natural log, and we can see here the slope of the tangent line is 1. The slope here of the tangent line looks like 1/2, and the slope here of the tangent line looks like 1/3. Now we can reason from this that this means that the derivative of natural log is actually just 1/x. And we can see here it's really steep, and then it gets less steep up here, but it's always positive. So our derivative is going to look like this. But since it's always positive, we actually don't need this other part of the graph. And we are back again with Sarah. Sarah, can you please solve this equation?
Right. I'm all so like using like threes.
Oh yeah, the same.
Right. I don't go back. I don't remember all of them. I can do them.
Now we have this function. Let's talk about it. So here we can remember that the derivative of natural log is just 1 over x. So this is just 1 over x plus 1. There's our answer. And our next contestant,
Kai.
Kai, can you please draw the function e to the x? Nice! Now can you please draw the derivative? Fantastic! Kai's graph was fantastic. Let's go over here and explain why his graph was so correct. Here we can see on Desmos, we have function a to the x and function f prime of x. We have the slider too, and it moves back and forth, but when it hits 2.7, the graphs perfectly align. And that is why the graph of e to the x is itself, because e's numerical value is 2.7. Okay, and our next contestant,
Then you can start getting into
Maddie, can you solve this problem?
level or paragraph level, and a lot of things are gonna, they'll do proofreading, but no one's gonna actually go back and look at what are all the different types of
That's
rhetorical
correct.
that you use.
Now we have this function. Let's go over it. We have the outside function and the inside function. First, let's solve the outside function. The outside function is e to the 2x. Because remember, e to the x, the derivative is itself. Now, let's solve the inside function, which is just 2. There's our final equation. Thank you to all the participants who participated in this episode of Math or Lose. I'm Lucia, your host, and I'm signing off.